Dear students, in previous videos we have learned different type of electrical symbols of different electrical components. With the help of that electrical symbols, we have made the different electrical symbols of different electrical components. As you can see in this slide also, we have got a electrical circuit. Like if I mention to you, then there is a electrical circuit. In that electrical circuit, what we have got in that electrical circuit, we have got an electrical cell, we have got electrical bulb, we have got a switch, and you can see here is also there are the wires. That means in that simple electrical circuit, we have got the four electrical components. What are the four electrical components? Number one is electrical cell, number two electrical bulb, number three electrical switch, and number four is wires. So with the help of that electrical components, we are make an electrical circuit. That is the electrical circuit which shows to us, that is called the physical circuit. That is what we call that. It is called the physical circuit. The circuit which shows to us, that is called the actual or real physical circuit. But how we are able to represent this electrical circuit by its symbols? That can be represented by its symbols as it's shown into the figure. The figure first which I am indicating to you, and there is a second figure. There is a difference between these two circuits. Like in the first circuit which shows to us, in that circuit what we have got the symbol of electrical cell, we have got the symbol of electrical bulb, as well as we have got the symbol of electrical switch, and the wires are represented by simple lines. But here it is mentioned the two things. What are the two things here is mentioned? There is a closed electrical circuit and another is called the open electrical circuit. So first of all, we need to understand what is the closed electrical circuit and then what is an open electrical circuit. First of all, a definition has given to us a simple electrical circuit. A simple electrical circuit can be made by using a cell, electric bulb, switch and wire. Now the second thing has given to us that the bulb glows only when the switch is in on position and the circuit is closed. In which position the bulb can glow? The bulb can glow only when the switch is in on position. As you can mention here, there is a difference. That means the first position which is indicating in that encircled area, that is called the switch is in on position, and the second position in which encircled are shown to you, that is called the electrical switch in off position. So whenever there is a proper flow of electric current through the electrical circuit, then only it can glow the bulb. And if there is no flow of electrical current, then we can say that there is no glow of electrical circuit. So basically, how we are able to represent this physical electrical circuit by symbols, that is the representation of the electrical circuit. So what is this representation? This representation of a physical electrical circuit by its symbols is known to be as a circuit diagram. Whenever there is a physical electrical components are there, we have to be represented by them as a electrical symbols. What is the utility or what is the application of the circuit diagram? The circuit diagram is the convenient way to represent the physical electrical component in their electrical symbols, because it can give us the convenience, and that is also, in another word, we can say that it is the pictorial representation of the physical electrical components in the context of electrical symbols. So that's why the circuit diagram is play a very important role, as there are the variety of electrical appliances are there. Like if we are talking about a simplest way, that like there is a washing machine is there, so washing machine or a fridge, they all have some kind of electrical circuit. If we are going through the manual of these electrical appliances like washing machine, if we are going through the manual of that particular appliance, then we can find out that in the manual also they have given some circuit diagram. So what is the utility of that circuit diagram? The utility or application of the circuit diagram is, if any fault is occur into that particular electrical appliances, then with the help of the circuit diagram we can easily point out or find out where we can have the problem is there, and with the help of that particular engineer or electrician can easily sort out that problem. That's why the circuit diagram is play a very important role. So so this is the representation of circuit diagram. And in previously I have also mentioned to you how we are able to show the flow of electric current into a electrical circuit. If we want to represent that in like in that picture, if we are going through that, then in the first picture, if we want to show that how the electric current is flow, then the electric current should always flow from positive to negative. This bigger line is representation of positive and the shorter line is representation of negative terminal. How we are able to show that the electric current is flow in an electrical circuit? The simplest way to represent that, by conventionally we always represent that the electric current is always flow from positive to negative terminal. This is your positive and this is your negative terminal. So the current will flow like this, and in that condition it is called the closed electrical circuit. When there is no electric current is flowing, that means there is no presence of electrical current, then how we are able to represent? We are not showing any kind of flow of electrical current, and in that situation we show that the switch is in off position. And in that case you can see that we are also not indicating by the uh, by the lines which indicate that bulb is glow. So that is the simple electrical circuit and the representation of the circuit diagram. So that is, in that way we are able to form the electrical circuit into its electrical symbols. Now there is a question has given to us: if the filament of the bulb is broken, would the circuit be completed? Would the bulb is still glow? The answer is that if in any case the filament of the bulb is broken, then that circuit is not considered to be the completed, because in that case the bulb cannot be glow. So we can say that if the filament means, if we are going through the bulb, then the mid part of the electrical bulb is known to be the filament. That is, in that picture if I want to show to you, then the end circle part is known to be as a filament. So filament means, it is a filament is a type of wire in which when the electric current is flow, then it got heated, and when it's got red heated, then that heat is turned into the light. That means that is the way the electrical bulb is working. And basically the filament of a normal electrical bulb is made from a particular material, through which when the electric current is flow, then it got heated, and due to that heat it converted into the light. That is the basic fundamental of an electrical bulb. When a large current is flow through that, it got heated, and when it got heated, due to that heat it turned into the light energy. That is the called the filament of the bulb. And in any case, if that bulb filament is broken, then we will say that the bulb is not working properly. sometime whenever we just switch on, then the bulb does not glow. Then we should check out carefully the bulb, either the filament is broken or not. So when we are look into the bulb, then if there is a broken wire inside it, then we will say that the bulb does not glow. That means we will say that the filament is not properly connected. That is known to be the filament of the bulb. So bulb filament is play a very important role. What is the important role it's play? When large electric current is passed through from the filament, then filament got heated, and that heat is converted into the light energy. Now we will go through the first effect of electric current. There are the two type of effect of electric current we will study in this chapter. The first one is called the heating effect of electric current. That is the first one, that is called heating effect of electric current. And second is called the magnetic effect of electric current. Now to understand the heating effect of electric current, we will perform the first activity, which is the activity 14.2. To understand better, we just utilize the previous activity circuit diagram. The previous activity circuit diagram means that is the circuit diagram which shows to us, that is figure 14.9. In that circuit, to perform that activity, what we required, what is the material we required? We required an electrical bulb, that is your number 1. Second, we are required an electrical cell, that is number 2. We are required the electrical switch, that is number 3. And we have required number 4, the wires. So basically what we required in that, to perform that activity, we required electrical cell, we required electrical switch, electrical bulb, and connecting wires. With the help of that, what we are going to do is we are just try to form an electrical circuit like we have shown in the figure. Also in that slide also the similar kind of electrical circuit are there. After that, what we are going to do, after take that all the material, we just make an electrical circuit shown in that figure. That means what kind of figure we are talking about? This is the figure we are talking about. And how we are able to form that electrical circuit? It is very easy. That is the representation of electrical cell. Then we are representing a switch. Then we are representing, this is your electrical bulb, and we are connected like this. Okay, in that way we are able to connect it. This activity has to be done using only one cell. That means that is a condition has given to us that we are using that activity by only taking a one cell. That means we are not increasing the number of cell in it. We are only just taking a one cell. Now what we are going to do, what is the first step after connecting all these electrical circuit? First of all, we just keep the switch in off position. That means that is the condition. This is the first condition which we have to perform in 14.2. That means we have to be just keep the switch in off position. Can the bulb glow? The answer is no, the bulb does not glow. What is the reason? The reason is that electrical current does not flow from the electrical circuit. That's why no electrical current is flowing through the electrical circuit. That's why the bulb does not glow. If we try to touch the bulb, what we feel? When in that case, when we try to touch the bulb, then we feel that the bulb is cool, or we can say that the bulb, when we are trying to touch that, or in another words we can say that we can easily touch the bulb. So that is the reason we have given in it. That means when we try to touch it bulb, then we do not feel any kind of warmness in it. Now what we are going to into the second step. In the second step, now what we are going to do, we are just make the circuit into the on position, a circuit into the on position, or electrical switch into the on position. That means that is the second situation in which what we are going to do, we are just try to switch on the electrical switch. That is the condition in which we are just try to switch on the electrical switch. In that condition, the electrical current will flow, and in that situation we can see that the bulb is glow. What is the reason the bulb is glow? The reason is because the electrical current is flow through that electrical circuit. We just try to flow the electrical current about 2 to 3 minutes in that case. After that, what we are going to do is again we try to touch that bulb. In first situation, when there is no electrical current and when we try to touch the bulb, then we can feel that no warmness is there. But as we switch on the electrical circuit and flow the electrical current through that electrical circuit, and in that case means when the electrical current is flow through that electrical circuit, or in another word, when the circuit is closed and when we try to touch the bulb, what we will feel that. So in that case, what will happen, when we try to touch that bulb, then we feel some kind of warmness is there. So where that warmness is come from, that is the question is arises. Again, when we try to touch the bulb in the on position, then we feel that there is a warmness. Again, what we are going to do, after moving the switch back to the off position, and again when we touch the bulb, what will happen, when we just switch off the bulb, then after we are just going to touch the bulb, then we feel some kind of warmness in it. So what is the reason why this kind of thing is happen? Because when the electrical current flow through the electrical bulb, then it got heated. So that is the reason, that is the basic thing by which we can understand that when the electrical current is flow through that electrical circuit or from the electrical bulb, then it got heated, and due to that heatness, what is the reason that the bulb got heated? The bulb got heated because electrical current is there. So that is known to be the heating effect of electric current. What is the basic definition of heating effect of electric current is there? The heating of electric current is mentioned in here is when electric current flows through a wire. Here from a wire, the wire gets heated. This is called the heating effect of electric current. So what is the basic definition of heating effect of electric current is when electric current flows through a wire, the wire gets heated. This is called the heating effect of electric current. Basically, in that activity, what happened, when the electric current is flow through the electrical bulbs, in electrical bulb there is a filament is there, and in filament we are using the wires, a special type of material we are using, and that material, when the electric current is passed through from that wire, then that wire got heated, and when that wire got heated, and then it turned into the light energy. So that's why that turned into the light energy. So who's responsible to make that filament into the hot position, or who is responsible to make that bulb into the warm position? The answer is electric current. That's why, because that effect is created because of the electrical current, that's why it is mentioned here is that the heating effect of electric current. So that is the basic definition of heating effect of electric current. Then when electric current flows through a wire, the wire gets heated, and this is called the heating effect of electric current. To understand better, we are going through the next activity. In that activity, what we are required according to the picture, we have got the required the two nails. Then there is a wire, it is mentioned here as, if you are just go through it, then there is a wire, it is called the nichrome wire. That nichrome wire is utilized into the electric heaters. We can easily get this nichrome wire. If the wire which is used in electrical heater is discarded, then we can easily get that nichrome wire. After that, we have got the electrical cell, we have also required the electrical switch, and we have got the connecting wires. These are the basic requirement to perform that activity. Now what we are going to do, we make an electrical circuit as shown into the figure. Like we have make all the things are made from the electrical symbols. Here we are not representing any electrical component by its physical structure. All the things is represented by its symbols. It is electrical cell symbols, it is switch symbol, the connecting wire is represented by lines, and the nichrome wire is also represented by its line. Now what we are going to do, we are just trying to make an electrical circuit as shown into the figure. Take a 10 centimeter long nichrome wire and tie between the two nails as shown into the figure. Now what we are going to do, we after setting up all these components, we are just switch on the current and we just flow the electrical current for few seconds. Suppose 10 to 15 seconds we just flow the electrical current. After a few seconds we just try to touch the wire, then we feel the wire got heated and the wire feels hot. Then switch off the current and after few seconds touch the wire again, it does not feel hot. So what we are trying to do in that activity, when we are just connecting all these components for few seconds, we are just try to flow the electrical current and touch the wire, we feel hot. When we switch off the current and after the few seconds when we try to touch the wire, then we feel that it does not feel any kind of hotness is there. So this shows that when electric current flows through a wire, it gets heated. So from that activity, what we trying to conclude, that as we have stated into the heating effect of electric current, that when electric current flows through a wire, the wire gets heated. This is called the heating effect of electric current. So that similar kind of thing is also happen in this nichrome wire. When electric current is flow through that electrical circuit in nichrome wire, then it got heated, and when there is no electrical current, then it does not get heated. So that is, we call that the heating effect of electric current. So again, in just summarize that what is the heating effect of electric current. When electric current flows through a wire, the wire gets heated. This is called the heating effect of electric current. If there is no electric current, then there is no heating effect of electric current is there. So electrical current is play an important role. When it flows from a material, special type of material like the nichrome wire, then it's got heated, and that is known to be the heating effect of electric current. I hope you understand what is the heating effect of electric current. Thank you very much.